Hi class, for these little problems we may be using some of the formulas that are actually out here. So I'm referring to these formulas along with any formula that showed up on the previous problems. And on this particular one, what they're saying is that, well, you're given two coordinate points, in this case, technically 3, 10. I'm just going to label this as your x1 comma y1. And then 4, 2, this will be our x2 comma y2. And they want the slope of the line that contains both of those points. So I'm just going to label it as m is equal to your y2 minus y1 over the values of x2 minus x1. And our y2 value here happens to be 1 minus the values of 10 over the values of 4 minus the values of 3. So we're looking at negative 9 over 1, which happens to be negative 9. That would be the slope of the line that contains those 2 points. Let me double check the algebra. Your y2 is 1 minus 10, and then the 4 minus the 3, which happens to be the 1. That's actually it for the first portion. On the second portion, which is part B, they want us to write the equation of the line, but they want this on points, point slope intercept. So in this case, they want this format. So let me just rewrite it. And for this particular problem, well, you're going to have the equation as y minus y1, and this is equal to m times x minus x1. And just to be clear, I'm just going to use the first coordinate point, but the requirements for this equation only contains that it has to have a point. So you could have used the 2's. So we could have used 4, 1. In this case, we'll use 3 comma 10. So this will be 3 and 10. And then the value of the slope we found to be negative 9. So as your main solution, we're just going to rewrite it. And in this case, you're going to have it as, well, let me write it as the equation is, and this will be y minus, this is supposed to be a comma, you guys, sorry. So we'll rewrite it as y minus, and your y1 happens to be the 10. This is equal to negative 9 times, in this case, x minus 3. And that is the equation of the line. In this case, it looks like the equation is not simplified, but that's actually our solution. So once again, so y minus 10 is equal to that. Okay, let me pause the video just in case you need to catch up before going into the next portion of the problem. Okay, let's go to part C. And in part C, they want the equation of the line, but they want us to express our solution in slope-intercept form. So that means that they are going to want this as y is equal to mx plus b. Now, on the good news is that you could use the previous solution and then just express it in terms of y. So I'm just going to say that we're going to use our y minus 10, which is equal to a negative 9 times x minus 3. And the only difference on slope-intercept form is that it's solved for the y's. So we have it in this format where y is equal to. So in this case, let me multiply those two values, and we'll have it as y minus 10 is equal to negative 9x plus the values of 27. And then we'll add the values of 10. So that our main solution, it's going to be negative 9x plus the values of 37. That would be our solution. And let me jump into the last portion, part D. Oh, that's supposed to be D. They're asking for the actual solution in standard form. So standard form actually has this format of the x's followed by the y's equaling constants. So in this case, let me use the previous solution. So use y is equal to negative 9x plus, and we ended up with 37. And then we have to express it as ax plus by is equal to c. So that's just going to require a addition of the 9x. So we'll have that 9x plus y is equal to the values of 37 for this particular one. And this is our main solution. And here, what we're actually doing is, well, using the two coordinate points and providing different ways of expressing the same equation. So basically, standard form, slope-intercept form, and point slope, it's the same equation, you're just expressing it in a different format. That's actually it for this one. Once again, this is supposed to be part D.